Hey folks, Dr. Humston here. We have lecture 1-4, looking at dimensional analysis. This is actually a concept that we've already been talking about and developing, but now we're going to explicitly talk about what it is, and it is basically a reliable method to doing conversions, and we're going to use units to guide us as we do this, right? So doing a conversion factor means switching from units to a different kind of units. And the dimensional analysis, sometimes also called unit analysis, is what is the method. So I've encouraged you to use this even when it seems like an easy problem, because if you can get this method down, then when we get to harder problems, maybe more abstract, less familiar context, we can follow the same method and do it. So the skill we're developing is calculating conversions. This is something that you need to be able to do. Sometimes between different unit systems, right? Metric and English, for example, and of course within unit systems, like within the metric system, and even within the English system, such as feet and inches, or pounds and ounces, or gallons and quarts. Okay, so all sorts of conversions. So once you get this figured out, you can do anything that you want with a conversion. I say that I say that this is a skill that you need to develop. And is that true even though Google exists? I mean, come on. Can't you just type it into Google? And indeed, this is actually incredibly useful. And yes, Google can tell you a simple one-step conversion, right? If you know exactly what you want, a certain number of grams into pounds, perfect. But of course, our life is not that simple, and we're going to be dealing with problems that Google cannot answer, right? For example, say the daily dose of ampicillin for the treatment of an ear infection is 115 milligrams of ampicillin per kilogram of body weight. What is the daily dose of the drug for a 27-pound child? So we're actually going to answer this question at the end today, but um, we see that you might be able to use Google for individual steps of your unit plan, but you can't just type this question in. Right? You first have to make the unit plan yourself. You have to interpret the question, put it all together in the right way, and then know how to do the individual steps. All right, so that's going to be something that uh, we're going to practice. And one reason that this is important, you cannot just simply look up the answers somewhere. So let's jump right in to one type of conversion problem. And today's going to be just a lot of examples. Okay, so let's say you're doing a metric conversion, and it's just a one step, one conversion factor. So the actual solution method would require 5 steps. And you'll get so good at these that you'll just do them without thinking of them as individual steps. But again, we're building up and developing this method. So let's do it right and say step 1, identify the given and asked for units. Right? What do you have? What do you want? Step 2, identify conversions between the given and the asked for units. Step 3, write out or express those conversions as 2 conversion factors, ratios. Step 4, multiply the given by the conversion factor that cancels the given units. As I've said, the unit you're converting into should go on top. Step 5, solve and round to sig figs. Okay, let's do these 5 steps with this question. Practice exercise 117 from your textbook. A tumor has a diameter of 5.5 nanometers. What is the diameter of the tumor in meters? Okay, so we can see how this is a one-step, or sorry, a one-step conversion, or one conversion factor from nanometers to meters. So what's given? 5.5 nanometers. What's asked for? meters. Step 2, what is the conversion factor? So we would look that up in your table, and it says 1 nanometer, 10 to the minus 9 meters. Okay, great. So we can write that as 2 separate conversion factors. And now we want to set up the actual calculation problem. Here's step 4. So the measured quantity. And then how do we know which one we want? We want to cancel nanometers and meters to be on top. And then we actually do the calculation, and we get 5.5 times 10 to the minus 9 meters. So here's the textbook answers. And if I go through these fast, that's fine. You can always pause it, right? But this should be the same as what we just did. Yep. Okay, how about another example here with 2 or more conversion factors. So we're going to be talking about stringing multiple conversion factors together, or a multi-step conversion. So the steps are fairly similar. Identify given and asked for units, and then identify the conversions between given and asked for units using the base metric unit as an intermediate. Okay, so that's the new step, right? So basically, we have the equivalent statements, the conversions for all of the other prefixed units with the base. So whatever you're starting with, you can convert it into the base, and then from the base into the desired. So those are the steps. Let's try it. Practice exercise 120 says, if a patient receives 25 deciliters of blood, the deciliter is a common unit of volume in medicine, how many milliliters of blood has the patient received? Okay, so given is 25 deciliters. What are we trying to find? Milliliters. So if you go and you look at a table, you will not see a direct relationship or a direct conversion between deciliters and milliliters. You could make one, but we should use what we have, and we know we have the base of liters, so we'll use that. So we want to write conversions for each of these to the base. You find that 1 deciliter is 0.1 liters, and 1 milliliter is 10 to the minus 3 liters. Now each of these can be written in 2 ways. And we want to start with the measured quantity and pick the first conversion factor that converts that into the base, liters. So we would pick this one to go to liters. And so deciliters would cancel out, and we now have liters. And we want to convert liters into milliliters. So we want that on top. And we see again that liters cancels out. We're left with milliliters, and stringing it all together, we get 25 times 0.1 divided by 0.001 equals 2,500 milliliters. Okay, we will stop here and return in part 2 for some more practice problems.